Oke, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone. So we are from Group 2. Would like to present about the landslide case study, which is the catastrophic waste avalanche at February 21st, 2005 at Lewi Gajah Dam site, Bandung, Indonesia. Okay, also from the group two itself is consists of me and also Agustin Nurul Rahmi. So for the introduction will be presented by me first. So on 21 February 2005, the Lewi Gajah site, Bandung, Java, Indonesia was affected by a large slide after heavy rainfalls. Second deadliest waste slide in history. It buried 71 houses and killed 143 people. And in 2005, solid waste generation in this region exceeded 14,000 cubic meter per day, of which more than half was generated within Bandung City. Household activities produced the highest volume of waste, which is consist of 7,000 of 700 cubic meter per day, and followed by industrial waste, which is 3,200 cubic meter per day, and also public facilities, 1,400 cubic meter per day. Out of the whole volume of waste produced in the metropolitan area, only 46% was collected, and most of the uncollected waste was dumped in the rivers, which is mainly the Citarum River, and burnt by the population or buried in the backyard or open dumping. And this is the waste problem in Indonesia. And as you can see in this figure, which is the source of the waste itself, which is can comes from the market, from the commercial, from the industrial, from the river, and also the residential. And for market is has 10%, and for the commercial is 15%, and industrial 15%. Also the river or garden 2%, and for residential is 58%. And the waste is collected, which is in the temporary landfill. Also can just directly go to the temporary landfill. SPA, 15% carried by truck, and then the uncollected waste is go controlled dump site, which is has 13% in here. And for the collected waste is go to the incinerator, which is has a 0.5%. And also it goes to the municipal solid waste dump sites, which is has 86.5% in here. So that is for the waste problem in Indonesia, and this is the location of the dump site itself in the February 2005 waste slide deposits. And yeah, as you can see in the pictures itself, this is the location of the Wigaja dam site. Okay. So maybe for this slide can be explained by Ami. For Ami, time is yours.
Okay, thank you for Areta. So in here, I would like to explain about the impact on environment from this landslide from the dam site in Lewi Gajah Bandung. For this picture, you can see here, this is actually uh, the waste that it's like a flow because the landslide is very big disaster. So this is full of waste. You can see like from the left one and also the right is full of the waste. So this is really make like a thick layer uh above the soil or the ground. Next please. And you can see here in the left picture. So from the B to the A, so the B is the dam site, and the A is the end of the landslide. So this one is very long distance to landslide, and you can see from this left picture, the A1, the A point, it looks like a big one, like it's larger than the B point. So the A1 is the residential, so a lot of houses getting impacted by this landslide. And also the right picture, you can see this one is the rice field. So this landslide also affected to the rice field, because you can see here, like you can see the methane gas over there, like a lot of methane gas. And then this is also this means this landslide case impact to the rice field and also to the groundwater, because rice field needs groundwater, right? So if the landslide or the waste going or just flowing over the rice field, it means that it will affect it, and then the groundwater will be contaminated by the waste. Next, please. Okay, so next, people living in Lewi Gajah and Batu Jajar heard three almost simultaneous explosions, like sounds a few minutes before the slide, and they all insisted that the sound was muffled and seemed to come from the deep in the ground. And a survey in February 2000 in the Lewi Gajah dam site indicated at a methane gas content of 2.3% per volume of gas at 2 meters depth, and almost 5% at a 4-meter depth. This is from the PT Perusahaan Gas Negara and Perusahaan Daerah Kebersihan Kota Bandung 2000. Then it can be assumed that the methane gas concentration would have been higher than these values at higher depths, and the explosion would have caused a substantial disturbance, which is quick increase in shear stress or decrease in shear strength of the saturated waste material. And those 3 days of heavy rainfall over 80 millimeters per day prior to the failure increased the weight of the waste and the poor water pressure in the soft subsoil, and water was reported seeping from under the dam 3 hours before the slide, and seeming to indicate that at that time the deposit was saturated, and hence a sudden rise of pressure could be at the origin of both the muffled noise and destabilization of the dam mass. Okay, next, please. Okay, the next of the impact on environment you can see in this table. So there are two scenarios. The first one is the failure due to dam mass saturation by rainwater. So the first one, the infiltration of rainfall decreased the shear strength of the dam, leading to its slide. And once in motion, the disturbance of the mass structure allowed large volumes of methane to contact smoldering waste, leading to the explosions. And then the material experienced a long run out because of the intrinsically low internal friction of the saturated waste material, aided by steam production. And the still hot material would have then also burned the victims of the slide. And for the scenario 2, the failure triggered by explosion. Heavy rainfall on the dam site led to increased water percolation through the waste material, and then the percolating water reached the top of the combustion zone deeply inside the waste mass, and the evaporation of the water produced an increase of gas pressure at the base of the dam that probably lifted up a part of it, and this one resulting in a sound like explosion during the liberation of the accumulated pressured gas. And then the vaporization and the lift up processes combine their effects to bring air to the combustion zone. And the second and probably the third explosion then occurred. And as the dis- stabilized mass began to slide, the fire propagated to the whole moving mass, helped by the significant amount of methane gas trapped into the waste material, which is numerous swirling flames were reported by eyewitnesses and were probably due to the gas trapped in the plastic bags. And the last is the combustion of each plastic bag within the moving mass produced gas that allow an expansion of the whole mass to occur. Once started, these mechanisms, as well as water vaporization, triggered a self-maintaining expansion during the transport, and the self-maintaining expansion responsible of a friction reduction within the waste material determined the unusually high mobility of the moving mass and can also explain why the whole material was deeply burned. Okay, next is the impact on solid waste management. So, since the 2005 disaster, the Louis Gajah Dam site has been abandoned and progressively recovered by the natural vegetation. And also, a big thanks to the high content of organic material in the waste deposits that allowed the formation of a soil. So, since the 2005 disaster, the Bandung municipality lacks a suitable site and finances to construct a new sanitary landfill. Therefore, West Java province has planned to construct two new sanitary landfills outside Bandung municipality at Lego Nangka, uh, which has 30 hectares of the area, and also the Louis Gajah with 40 hectares of the area to be used by Bandung municipality. And the contract has been signed in 2012, and both sites were planned to be operational in 2014. And another project that encompasses the construction of an incinerator is highly criticized for ecological seasons. Okay, so for the next topic will be present back by the moderator.
Okay, thank you so much, Ami. So I'll explain the rest of the materials. So for the authorities deals in this case, only after the 2005 disaster that the activity of the dump site comes to an end. The local official in charge of the site was charged for not respecting the official recommendations regarding waste disposal and was sentenced to jail. In parallel, the local communities complained about the closure of the dump site without appropriate alternative sustainable livelihoods. And although the disaster obviously brought some significant change in Lawigaja in the short term, the long-term prospects are bleak. A project by Environmental Protection Agency of West Java Province, or so-called BPLHD, has been planned for redeveloping a controlled landfill on the same site. And for the critical review of this case, so whatever the natural triggers of the waste the disaster cannot be dissociated from the extreme vulnerability of those marginalized people who died and suffered. And although the previous wastelands occurred in the past, the local government failed to both implement structural measures to stabilize the dump site and provide scavengers with alternative sustainable livelihoods. And the amount of waste dumped in Lewigaja actually sharply increased over the years before the disaster. Okay, so that's all from us. So in here we open the question from the group one. So each of you had to ask two questions. So if anyone had several questions, just raise your hand and unmute your mic. So for the session is open.
Thank you, Arata. I would like to ask about the study case for group 2. My question is, how did the accumulation of methane gas contribute to mechanical failure of the dump site And what does this suggest about the monitoring need of landfill gas in tropical waste site? I think that my first question, and my second question is imagine if you were tasked with designing a new management system for Bandung post maybe 2005. What key lesson from disaster will guide your decision, especially regarding landfill design, site selection, and community safety? Okay, that's all of my question. Thank you for group two. I'll give back to moderator.
Okay, Haikal, that's all for your question.
Yeah, that's all of my question.
So I think Haikal had several problems for the connection. So, Haikal, you can just send the questions in the message box. And for the rest of members of Group 1, kindly, as you can see in the figure, without fee, you can ask your questions, please.
Mm, Thank you. I have two questions. First, why were not proper safety measures like covering the waste and stabilizing the slope put in place, even though the expert and had already warned about the risk? Was this more about poor planning or a bigger issue with how waste is managed in Bandung? And then you told us that the methane level in landfill were dangerously high. And then, is there any possible, like, could something have been done earlier, like better gas venting to prevent the explosion and the landslide? Especially knowing the area often having heavy rainfall. That's all. Thank you.
Okay, thank you so much for the questions. So for the last one, Sifa, you can ask your questions.
Thank you, moderator. So my first question to group two, how did the interplay between unregulated waste deposition, methane saturation, and hydrological instability create a cascading failure at Lewi Gajah, and what systematic monitoring mechanisms could have prevented this disaster? And for my second question, Give, given the post-disaster shift toward planet sanitary landfills, for the example at the Lego Nangka, and contested incineration projects, how can Bandung reconcile rapid waste management needs with long-term environmental justice for marginalized communities depend on the dam sites? That's all from me. Thank you.
All right, thank you for the questions from the group one. So we already have collected all the questions and we will answer all the questions in the next meeting. So maybe that's all from us. We apologize if there's any mistakes from our presentation. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.